Metallic bonding is the attraction between metal atoms that have released their valence electrons and a sea of delocalized electrons. But what does this mean? Let's go into more detail.
Metal atoms have few valence electrons. This means that to reach a noble gas configuration, they lose electrons, which are negatively charged. When electrons are lost, the atom has a positive charge, resulting in a positive ion called a cation. The electrons that are detached from their atoms are called delocalized electrons.
The metal cations are surrounded on all sides by other metal cations. The delocalized electrons are attracted to the positive charge and are therefore drawn into the free space.
The delocalized electrons are free to move between cations and are often called a sea of electrons. The force of attraction between the positively charged metal ions and the negatively charged delocalized electrons holds the structure together and is called a metallic bond.
Metals have many properties. These include being able to conduct both electricity and heat in all states, being shiny, having high melting and boiling points, and being able to be shaped or drawn into wires.
Electrical conductivity means that electricity is able to pass through the metallic bond. Metallic bonds are good conductors of electricity because the delocalized electrons can move a lot. When a metal is hooked up to a power supply, the electrons can move and carry the charge.
Imagine dipping a metal spoon in boiling water. Within moments, the entire spoon becomes warm. But why? When a metallic bond touches something hot, the sea of delocalized electrons and the ions will vibrate faster. They then bump into other electrons and ions, and their energy is transferred. In this way, the heat energy will be spread to the entire metallic bond.
Luster means that the substance is shiny. Metallic bonds are shiny because when light hits a metallic bond, the light rays are reflected off the delocalized electrons, making it shiny. The close packing of the metal cations, preventing light from passing through it, makes the metal opaque.
The term malleability means that a metal is able to be bent into shape. Ductility means that a metal can be stretched out into a wire. When pressure is added to a metallic bond, the ions move while the mobile electrons adjust to the new arrangement. The sea of electrons then reform their bonds with the metal cations. This allows layers of cations to move around without destroying the metallic bonds.
This means that the temperature needed to break the metallic bonds and therefore turn the substance into a liquid or gas is very high. The attraction between the metal cations and delocalized electrons is very strong. So in order to break the attraction, a very high temperature needs to be applied.
Even though all metals share the same properties, they are all different. All metallic bonds have different melting and boiling points. Some are less shiny and some are less malleable.
But why? If all metals form the same type of bond, why are all the properties a little different? The answer is because of the difference in the force of attraction throughout the metallic bond.
When more electrons are delocalized, the attraction between the nuclei of the ions and the electrons is stronger, and when the atomic radius is larger, there is more shielding between the delocalized electrons and the nucleus.
Therefore, when the atomic radius is smaller and there are more delocalized electrons, the forces of attraction throughout the metallic bond are stronger.
Like anything, there is always an outlier that doesn't behave the same way. In this case, it is mercury. Mercury is a liquid at room temperature because the electrons in a mercury atom are bound tightly to the nucleus, which means that it is difficult for mercury to share its electrons. This means that the metallic bond that is formed is weak, so it takes very little energy to overcome the weak bonds, turning it into a liquid.
When metallic bonds combine with different metal bonds, the product is an alloy. An example of an alloy is bronze, a mixture of tin and copper. In bronze, the tin and copper ions form a 3D structure and attract the delocalized electrons, forming a metallic bond.
A metallic bond is the attraction between metal ions and a sea of delocalized electrons.
Metallic bonds are named after the element present.
Properties of metallic bonds include high melting and boiling points, thermal and electrical conductivity, malleability, ductility, and luster.
Properties change throughout different metallic bonds because of the strength of the metallic bond.
Mercury is a liquid at room temperature because of weak bonding.
Alloys are mixtures of different metals.
Created using Powtoon.